Okay, this review is for your Module 2 quiz you're about to take. Number 1 says you spend the same amount of money every week for lunch. In 4 weeks, you spend $120. Write an equation to show the relationship. We've been talking about writing equations from tables, so I went ahead and made a table. If in 4 weeks you make $120, then that means in 2 weeks you'd make $60, in 1 week you'd make $30. So in 3 weeks this would be 90. Weeks is your independent variable, that's your x. The amount of money you're spending every week is your y. If you are going to write an equation, you need the k, the constant of proportionality, which would be y divided by x. So if I take any amount in this table and I go do 120 divided by 4, I'm going to get that I'm spending $30 each week, and you would see that as true. 90 divided by 3 is 30, 60 divided by 2 is 30, and 30 divided by 1 is 30. So 30 is my k. When I write my equation, I want to write y equals 30x. That would be my answer. Number 2. What is the constant of proportionality on this graph? Write an equation for the line on the graph. Graph the line and write an equation for the line if the store was to increase the price of DVDs. Okay, so first it's asking us what's the constant of proportionality on this graph. Okay, again, remember k equals y divided by x. Okay, so these are your x values on your graph, and these are your y values on your graph. So you want to pick a point on the line that lines up exactly with your scale to where you can read your y and your x values. So my 4 on my x lines up pretty nicely with this 20 on my y. So that means my constant of proportionality is going to be 20 divided by 4. My k is 5. So that's going to help me write my equation that these DVDs, no matter how many I buy, they're $5 each. Okay, so it's asking me to, I wrote the equation, I found the constant. Now it's asking me to graph the line and write an equation for the line if the store was to increase the price. So you can come up with any price you want to increase these DVDs to. You just have to be able to graph it on this line. So let's say that I want to increase the price to $8 for every DVD. That means that my equation would be, instead of $5 for every DVD, would be $8 for every DVD. And if I was going to go graph that, that means that if I was going to spend $8 for every single one I rented, 2 would cost me $16. So I'm going to plot that point here. Let's say I rented, I'm 5. That would cost me $40. And I want to go ahead and graph that line through those points on the same graph. Okay, so one of your quiz questions will ask you to add a line to a graph that's already provided. Number 4, is 7/3 an integer? Why? Okay, 7/3. Remember this says divided by. Okay, 7/3, if I were to go divide 7 by 3, okay, we would actually get a mixed number. Okay, 3 goes into 7 twice, which is 6, with 1 left over, 2 and 1/3. Well, when you think about what an integer is, we talked about an integer being all whole numbers and their opposites, including 0. So is 2 and 1/3 a whole number, or its opposite, or 0? No. So you need to explain that in words. You need to say no, it is not an integer because it's not a whole number or its opposite. Okay, look at number 5. Is 18/9 an integer? Why? Okay, again, the fraction bar says divided by, so if I go 18 divided by 9, that's going to equal 2. Well, is 2 a whole number or its opposite? Yes. So here you're going to say yes, it is an integer because it is a whole number. Number 6, what is the unit price if 7 and 5/10 pounds cost $77.78? Okay, you have to remember the word unit means one. So when we set up our rate, $77.78 over 7 and 5/10, this is my pounds. I want to take my pounds down to 1. So I want my denominator to be 1 to find my unit rate. How did I get from 7 and 5/10 to 1? I divided by 7 and 5/10. Whatever I do to the bottom, I do to the top. So in order to get my unit rate, I'm going to have to go do some decimal division over here. I cannot divide by a decimal. I have to make my outside number a whole number by moving it to the back. I moved it once. Remember that whatever you do to the outside, you do to the inside. And then you divide like normal. So 75 goes into 77 once. I subtract. Can 75 go into 27? No, you have to show that up there. And bring down. 75 goes into 278 3 times. That's 225. And add a 0, bring it down. And 75 goes into 537 times. And when you subtract, you get a remainder of 5. If I were to add a 0 and bring it down and keep dividing, 75 goes into 50 0 times. But I can stop right there because remember we're talking about a unit price and money ends at the hundredths place. So I just have to go to the thousandths place to see what happens to my hundredths place. And in this case, the number to the right is a 0, so the 7 is going to stay the same. So my unit price should be $10.37 per pound. That is my unit price. Number 7 just wants us to fill in the table. Okay, we're completing the table for an object that goes 20 miles in a fourth of an hour. So a fourth of an hour goes 20 miles. That means that in half an hour, well, what do I do to go from 1/4 to 1/2? Okay, if you know about fractions, you're doubling times 2 to get to the half. So you're going to do the same thing to your miles. If I double 20, that would be 40 miles in half an hour. And how did I go from 1/4 to 3/4? Well, I did times 3, so I would have to do the same thing here, and it would be 60 miles in 3/4 of an hour. On the next page, number 8. Create a table that illustrates a proportional relationship. Do not use an integer for the constant of proportionality. Okay, we just talked about what an integer was. So we cannot use a whole number or its opposite. It has to be either decimal or fraction. That's going to be our constant. So if your quiz asks you to create a table, you can come up with anything you'd like as long as it's not an integer. Okay, so this is just an example of something you'll see. It's not the exact problem, but let's say I was talking about hours that I run, or miles that I run per hour. So in 1 hour, let's say I run 6.3 miles. Then that means in 2 hours I would be running 12.6 miles. And in 3 hours I would be running 18.9 miles. So to get my constant, remember it's y over x, I would go take my values and divide. That would be 6.3. And 12.6 divided by 2 would also be 6.3. And 18 and 9/10 divided by 2 would also be 6 3/10. So all these rates are the same. That's my constant. and it is not an integer. Number 9. If you dig 2/7 feet in 30 minutes, how many feet do you dig in an hour? Okay, so we have a rate of 2/7 feet in 30 minutes. And what do we know? We know that 1 hour is equal to 60 minutes. So I want to get from 30 to 60. How could I get from 30 minutes to 60 minutes? I would have to multiply by 2. I'm going to have to do the same thing to the top to get my feet in an hour. So when you're multiplying fractions, remember that you put whole numbers over 1, and you do top times top, that's 4. Bottom times bottom, that's 7. So that means I would go 4/7 feet in 1 hour. Number 10. Some hikers had an average speed of 2 miles per hour. Draw a graph to show how the distance is related to the time. Plot at least 4 points and draw a line through the points. Okay, so hikers that are averaging 2 miles per hour. So here's your hours, your x. Okay, that means in 1 hour they went 2 miles. I already had plotted these. So in 4 hours they went 8 miles. Plot that. Let's say then in 6 hours they went 12 miles, and in 8 hours they went 16. Okay, so when you draw your line, I should have drawn it this way. So it's not the green one, it's the black one. And that's all you would have to do there. So you're plotting your points, you're drawing your line, and that's all you have to do. Number 11. If a person swims 3.8 miles in 20 minutes, how far can he swim in 2 hours? Okay, we could do this one a couple of different ways. We're talking about miles and minutes. So 3.8 miles in 20 minutes. Oh, I already put minutes. So first I'm going to take it to 1 hour, and you know that there are 60 minutes in 1 hour. So how did I get from 20 to 60? I multiplied times 3, so whatever I do to the bottom, I'm going to do to the top. 3.8 times 3. Remember, when you're multiplying decimals, you do not line them up. And there's 1 decimal place value on the top number. There's none on this bottom number. Altogether, there was only 1, so you come from the back and you put it back 1 time. You move once. So that's 11.4 miles in 1 hour. But the question was, how about for 2 hours? So 60 minutes is the same as 1 hour. If I want to figure out miles, 114 in 1 hour, but really now I need 2 hours. What did I do to 1 to get 2? Times 2, so I would have to do 11.4 times 2, which doubling it would just be 22.8 miles in 2 hours. Number 12. How do you simplify this complex fraction? What does the result tell you? Okay, so to simplify this, I need to take down my 5/7 of a pound down to 1 pound. Again, how do I go from 5/7 to 1? I'm going to have to divide by 5/7. Whatever I do to the bottom, I'm going to have to do to the top. So $8 is being divided by 5/7. Remember, you put whole numbers over 1. Well, division of fractions, that is when you use the keep it, change it, flip it. So we're going to keep the 8 over 1. We're going to change division to multiplication. We're going to flip the 5/7. The reciprocal would be 7 over 5. And then top times top, that's 56. Bottom times bottom, that's 5. Because we're talking about money, when I go divide this, instead of leaving it as a mixed number, in fraction form, I want a decimal. So I'm going to go show my division over here. 56 divided by 5. obviously you know that's going to be 11, but we want to put a decimal, attach a 0, take it down, and 5 goes into 10.2 times, which is the same as $11.20 per pound. So what does the result tell you? You would have to say that it is $11.20 for every pound. So basically you're just explaining the unit rate. Number 13. A baker bakes 10 dozen cupcakes in 15 minutes. Write an expression for the unit rate per hour. So an expression is different from an equation in that an equation has an equal sign and an expression does not. So it doesn't want you to solve this. It wants you to just write the problem, the algebraic expression that you would use to solve it. So it's going to involve numbers and or variables in an operation. So let's see, we're talking about 10 dozen in 15 minutes. But you would have to know, it's asking for a unit rate per hour. Well, then you would have to know that for every 15 minutes, it's a fourth of an hour. So we're going to change this to 10 dozen for 1/4 hour. And to get our unit rate, we would end up having to take our 1/4 denominator to 1. Again, how do I go from 1/4 to 1? I'm going to have to divide by 1/4. Whatever I do to the bottom, I'm going to have to do to the top, divide by 1/4. So the expression that I would want to write, how I'm getting my unit rate, would be 10 divided by 1/4. That's the expression I would have to solve to find my unit rate per hour. So you don't have to solve it. You just have to write the problem you would use to solve it. And the last one, number 14. What is K, the constant of proportionality for this table? Again, K is equal to Y divided by X. So you want to line up all your columns and do that division. So 250 divided by 25 would give me 10. 500 divided by 50 would give me 10. 750 divided by 75 would give me 10. And 1000 divided by 100 would also give me 10. So you see that constant rate staying the same, showing the relationship between our x and y values. That is our constant of proportionality, so K equals 10. Okay, so these are just some of the problems that you will see similar ones on your quiz tomorrow, but don't forget there's also vocabulary. So don't forget to study that vocab.